Last, oh, and some people have come, didn't start the first session, and I guess even a couple maybe not the second session. There are 3 things that were passed out, and if you don't have all 3, you should take one of the ones you don't have after class. One is a list of my publications. One is suggested readings, and one is a propaganda piece that I call my 2 nights paper, because that tells you what most of the course is about. The last time, or the time before, I guess, I had put the expression WFF on the board for the logicians' well-formed formula, and I told you that they pronounce it woof. That's the way I learned to pronounce it from Wilfrid Sellars, philosopher, and now I find that my colleagues in the Philosophy of Science Center tend to say woof with an I rather than woof like a dog. So take your pick. Woof, woof. Last time, oh, one other thing. That is the reference to the material that I used to spend a half of a class on. But those of you who are concerned about the legitimacy of the word true as used in science, or have a, as I call it, a truth phobia, if you want to get the details of the argument about that, in which Carnap shows to his satisfaction, and certainly to mine, that Kaufman's throwing the word out of the vocabulary is A, needless, and B, becomes self-contradictory on the grounds I mentioned last time. It's a detailed discussion, and it is somewhat better than the original article which appeared in a funny journal, I think, called Philosophy and Phenomenological Research. That's all right if you have access to that one. The main point is made, but when it was reprinted for the Feigl and Sellars readings, Carnap was asked, are there any things that you would like to change a little bit or add or alter the vocabulary a little bit or whatever, and so it is not identical with the original publication, and it is an improvement. That, when you read that article, that should make you delightfully relaxed about using the metalinguistic predicate true. And as long as you keep in the back of your mind that if it's highly probable that Caesar crossed the Rubicon, then it is highly probable that it is true that Caesar crossed the Rubicon, that if you don't mind saying it's highly probable or the evidence shows or any reasonable person should believe that Caesar crossed the Rubicon, then you shouldn't be nervous about saying any reasonable person should accept the truth of the statement that Caesar crossed the Rubicon, since their content is the same, even though one is in the object language and the other one is in the mental language. At the end of the hour, I was talking about verisimilitude. Popper's concept, verisimilitude, meaning looking at the Latin similarity to truth. And I guess I had mentioned that it is an ontological concept. That is, it refers to, in the correspondence or semantic theory of truth, it refers to whether the state of affairs expressed by the sentence obtains or not, meaning in the eyes of omniscient Jones. It is not an epistemological or evidentiary concept. Therefore, it cannot be equated with terms like probability. I actually had some nitwit journal editor change my vocabulary from verisimilar to probable. Editors have become increasingly A, ignorant, and B, high-handed since I was a youth. Popper would have a stroke, of course, if anybody identified verisimilitude with probability. Probability, when you're talking about evidence, is the relation between the evidence and the statement, theory, or whatever that it's evidence for. Verisimilitude is not a relationship of a statement to its evidence. It's a relation of a statement to the world, whatever is the case on the correspondence view. Caesar crossed the Rubicon is true if and only if he did. Right? What more could I say? Caesar crossed the Rubicon, Quine Corners, is true if and only if he did. Whereas Caesar crossed the Rubicon is probable upon the evidence in the Vatican Library for you and me, and it's probable on visual evidence for the centurion that was crossing with him. And it's because of that difference between the content of a statement and the evidence that supports you in believing it that the old Schlick definition, meaning is the method of verification, went by the boards. Now, verisimilitude is a matter of degree, just as confirmation is a matter of degree. I said last time that even if you point out that a given proposition is either true or false, maybe we don't know which, but it is either true or false, that doesn't mean that scientific theories are either true or false without matters of degree, because they consist of more than one sentence, and secondly, because even the single sentences of a scientific theory are not about fundamentally simple things, but about complexes. Everything we talk about in psychology is about complexes, isn't it? Brains or minds or people or societies or thoughts or response sequences or whatever are complexes. If there are any simples, they're quarks and gluons. Everything else from chemistry up is complexes. Now, there is the old problem, is the universe infinitely deep? We don't discuss that in this course. That's beyond the scope of the class. I mean, if gluons are made up of somethings and the somethings are made out of widgets and it goes on forever and ever and ever, and omniscient Jones knows it's infinitely deep, well, and that's one thing nice about that, means physics can go on forever, right? Because you'll keep learning about the particles that are the particles and so forth. We don't talk about that in psychology because we never deal with the simple. All the stuff we talk about is complexes. And since a scientific theory is a collection of sentences connected in certain complicated ways, scientific theories, like news stories, can differ in how much truth they have. Now, strictly speaking, one would say that a scientific theory is false, period, if it contains any false statement. Because if the theory is a conjunction of statements S1 and S2 and S3, say the postulates of a formalized theory together with all of their consequences, all of the theorems, then the falsity of any one of these, putting a tilde on any one of them, this is false, not S3, automatically means that on the left is false, of course. That's not a question of your philosophy of science, is it? That's a question of, again, that's undergraduate logic. Falsifying any conjunct in a conjunction falsifies the conjunction. So in that sense, you would say, well, if you insist on everything being two-valued, either true or false, then of course a scientific theory which has an itty-bitty piece of error in it, it consists of 12 postulates, and some of them are quantitative, and one of the quantitative postulates includes Planck's constant, and the number you are writing down for Planck's constant is off in the third decimal place. Then, in the sense of logician, the theory is false, because it contains one false statement. But that doesn't get rid of the notion of verisimilitude. That is to say, a scientific theory that consisted of 10 postulates, one of which is a little off, is in better shape than a scientific theory that consists of 10 postulates, all 10 of which are false. Agreed? In that sense, scientific theories can be like news stories or novels based on a real character, historical novels. And so you put in some true facts about Napoleon, and then you put in your conjectures about Napoleon, and then you make a completely imaginary conversation about between Napoleon and Josephine on a certain occasion. Okay, well then, if we looked upon that narrative the way we look upon a scientific theory, a crude measure would be to go right through the novel and take all the sentences and classify each sentence as T versus F and count the percentage. That's the crudest measure of verisimilitude there is for a collection of statements. count how many of them are true and how many of them are false. It's too crude to work. Efforts to do it that way by followers of Popper didn't pan out, were abandoned. And I think I told you last time that Popper gave a definition of verisimilitude that was criticized on certain formal and even mathematical grounds, and I do not want to go into that. And he tried to repair it, and that was criticized. And there is even now some dispute among logicians, including people sympathetic to Popper, as to whether it can be done, at least in the way they like to do it. There was the notion of you take the truth content minus the falsity content, or truth content minus falsity content over total content. And content was defined in the way the logicians like to do things as the whole consequence class, which is infinite in number. And then you get into some measure theoretical problems about infinities of these numbers. It is one big mess. And people have almost abandoned trying to fix it up. There is an article in the last issue of the British Journal for the Philosophy of Science summarizing the state of things, and it is not satisfactory. I repeat, we have to have it. We can't get along without the notion that some theories are truer than others. The scientist doesn't go about his work unless he believes that he can improve a theory which, taken literally, is false, by altering it in certain ways. It's common discourse in all sciences that I know anything about that Jones's theory isn't quite right, but it's an improvement on its first edition. Or Jones's theory is in trouble, but it ain't in as bad trouble as Thisbe's theory is. And geologists, physiologists, geneticists, astronomers, everybody has to talk this way to carry out the scientific enterprise. Fund-granting agencies in deciding who should get money to study a theory have to think that way. If we didn't allow ourselves to think that way in the social and psychological sciences, I don't know how Bethesda would decide who gets the money, since all the theories are false. But some are falser than others. So we have to have it. But don't feel bad. We have to have the concept of probability to do our thing. And that is not satisfactorily explicated after all these years. There isn't even agreement among logicians as to whether there are two kinds of probability or only one. You'd think at least that would have been decided. Maybe they might say, we got to clean up this definition, or this isn't quite right. But at least we know there's one thing we're trying to explicate. That's not agreed on. Carnap said there were two kinds. We'll talk about probability 1, probability 2 later. Reichenbach said, no, there's only one kind. Von Mises said, yeah, there are two kinds, and one of them is sinful, so we shouldn't do it anymore. And there you were, von Mises, Reichenbach, and Carnap. And they'd all thought hard and long and were deep thinkers about the concept of probability, and we still don't know whether we should hold the identity or the disparity conception. Some of you were doubtless taught in some statistics course that there's only one, because R.A. Fisher was a very dogmatic man. But that is not settled, and you can't settle it by looking at gamma functions. I mean, it's a philosophical and not a mathematical problem, whether there are two concepts of probability or not. For most of our purposes in psychology, when we use statistics, the frequency concept is adequate. When we are not using statistics, when we are evaluating theories or interpreting a patient's dream or sitting in a case conference where we are not doing t-tests, it's not clear whether the frequency theory of probability is adequate, whether we need Carnap's other kind of probability as well. But we will spend probably a whole session on the one subject of probability before we're through. I will, since we're running behind, as usual, I'll confine myself to a single example of degrees of verisimilitude for now. And we'll use some other examples. And I'll take an example outside of psychology because it's easier and it's settled. And that's the kinetic theory of gases, the kinetic theory of heat. As you know, if you took physics, the brilliant insight of the kinetic theory, which was already beginning to be formed in the 1700s. Even Bernoulli, I think it was, had a form of it. It gets elaborated in the 1800s by people like Maxwell and Lord Kelvin. And then in the United States, the mathematics in great detail by, got a blocking, the guy at Harvard. The big insight of the kinetic theory is that you could explain the equations about gases, their volume, their temperature, the pressure. You could explain that in the sense you could derive it by the principles of mechanics, so that the theory of heat, at least of that kind of heat, not talking about radiant heat, which is photons, electromagnetic waves, but the heat that you have in your hot soup, the heat that flows from one container to another, the heat that moves the thermometer reading up, was reduced to non-thermal concepts, namely the concepts of mass, velocity, collision, momentum, and the like. And the way they did that was to imagine that a gas, say you've got a cylinder with hydrogen in it, consists of these small particles called molecules, and that these particles act like billiard balls in that they have a mass and they can have a velocity components, that they can collide with each other or with the walls of the container, and that what we call at the molar or macro level pressure, when the gas drives the piston in the cylinder, pushes it out, is due to millions and millions of little collisions of these small particles with the head of the piston. So that meant that concepts like temperature and amount of heat, corresponding to the old caloric, because temperature is degree of heat and the other is amount of heat, it was an important insight even to realize those had to be split. A physicist named Black first realized that. Degree of heat, amount of heat are two different things. How much heat it takes to heat a certain substance to a certain degree is therefore defined as its specific heat when compared with water and all of that. The notions of heat were then reducible to mechanical notions. And that kind of reduction is always intellectually pleasing to scientists. There is a species of human being that dislikes it, but they don't tend to show up in this building usually. The scientist likes to be able to reduce one predicate or functor or class of phenomena to another class, quote, lower in the hierarchy of explanation. Now, in order to do the mathematics of this, they had to make some idealizing assumptions about these particles. And the first one was that these particles are so small that you can neglect their size. So that the theory treats the hydrogen molecule as a point mass, as a mass that is at a point in space but does not fill any space. Negligible volume. A little more elegant way of saying it, the radius is negligible compared to the mean free path. That means, on the average, how long does a hydrogen molecule move before it hits another one? And if you say that, well, to do the math, we'll assume that that's so small that we won't count it as being anything at all. Point masses. Billiard balls that are points banging against each other. Secondly, you assume that there are no attractive forces between them. Gravity, as you know, is the weakest of the 5 forces. There's a little hassle on us to whether there's a 6th goofy one. Involves replication problems, even in physics. But suppose there are 5, the strong and the weak nuclear force and the electromagnetic and gravitational, and the idea was that these things, these point masses, while theoretically they have to obey Newton's law of gravity, so that they have to attract each other, that again, because they are so far apart, taking the inverse square law into account, that we will neglect the fact that they might have an itty-bitty gravitational attraction. Now, if you assume that, hydrogen, a bunch of molecules that are point masses, occupy no space, and have no gravitational forces between them, and the electrostatic forces amount to the mechanical forces in the sense that on impact, these point masses are like billiard balls, but of course one knows that they didn't know about electrons in 1865, but we now would say, yes, that mechanical impact problem amounts to when they get close enough, the electrons in the outer rings of the atoms start to repel each other. And from that, making those assumptions, you put this into your calculus, using the word calculus now in a broad sense, not what Newton and Leibniz invented, but a formal system. Set theory, mathematical logic, algebra, those are all calculi. You put those into your calculus, which is a formal truth-grinding machine. And with those assumptions, put them into your truth grinder, and it spits out PV equals RT. This is a constant. This is the Kelvin temperature above absolute zero. This is the pressure, and this is the volume. If you hold this constant, you have Boyle's law, and if you hold pressure constant, you have Charles' law, okay, in chemistry. When you put the two together, you get PV equals RT. Well, it fits the data very well, except when you compress and compress and compress and compress and also get very low temperature going. And when we get low enough temperatures and small enough volumes for a fixed amount of hydrogen, this thing falls apart. Doesn't fit the data. If you can find yourself to any of the kinds of pressures we run into in ordinary life, anything that you would do as a sophomore in a physics lab class, PV equals RT works like a charm. I mean, there's your hyperbola, and there's your experimental points, and it's just lovely. But when we get very, very high density, it doesn't work anymore. So what do? Well, we don't say the way a simplistic form of Popper would have said. Popper says he never said this. Well, he never meant it, but he darn near said it in the first edition. You wouldn't say, oh, falsification, boing, instant rationality, modus tollens, P, horseshoe, Q, not Q, therefore not P. The Q here is that curve. The dots don't fit, so we got a modus tollens falsification of the kinetic theory of heat, so we'll go back to the drawing board and make up some gunk or sludge instead and drop the kinetic theory. Nobody did that. So they didn't play it like orthodox Popper or what Lakatos calls Popper zero. Popper gets mad at Lakatos for, he says, I don't have subscripts on me, but Lakatos is fond of this game, and so he has Popper 0, Popper 1, and Popper 2, and I think there's even Lakatos 0, 1, and 2 now. Popper 0, Popper 1, and Popper 2. Now, maybe Popper 0 doesn't exist or never did exist. There are certainly passages in the 1934 book that can be taken that way. Let's put it like that. It's not a big thing whether Popper 0 existed, is it really? Except in terms of historical justice. For our purposes, you can read certain passages in the 34 book as being Popper 0, as holding very strictly to modus tollens, and hence instant rationality, and hence when we go into the lab and take these extremes of compression of this gas, then we would have to abandon the kinetic theory. Well, now let's be clear about that before I tell you what happened next. To abandon the theory is not the same as to say it was falsified, because I might say the theory is falsified, but I'm not going to abandon it, and you might ask, well, what the dickens would that mean to a rational person? Well, it means I think it's the best that we've got, and I'm going to fool around with it. That's what that means. If I'm an instrumentalist, of course, I can say that without any embarrassment, right? If I'm an instrumentalist, I don't care about whether the thing is true or not. So I just say, well, it holds throughout most of the range, and it enables me to predict and control. And if you're an instrumentalist, that's what theories are for. But if you're a realist, it's the other way around. It's the theories you care about, their truth, their verisimilitude, and the facts are a means to that end. So if you're a realist, you have to say something responsible about this. But you can. You can say, yeah, it is false. Playing at Popper Zero, it is false. But it's only a itty-bitty false. And that being true, I'm not going to abandon it. So there's a distinction in the history of science that corresponds to a logician's distinction, quite clear, between falsification and discarding or abandonment. I appraise the theory, and that includes saying, is it literally false? And secondly, how badly false is it? And if it's literally false, I will, if I'm playing Popper Zero, I will say, it's false. Yes, it's false. Capitals, F-A-L-S-E, false, yes. Loud and clear, but only a little bit. And there's enough truth to it that I'm going to see if I can amend it or patch it up. And that's what they did. And they were in an excellent position to do that because when they had first formulated it, they knew that it was literally false. Nobody that I know of who was a believer in the kinetic theory of heat and was dealing with that Maxwell and Kelvin math. Gibbs is the Harvard guy, Josiah Willard Gibbs. Nobody who was dealing with the math that I know of believed that these were really, literally point masses, that the hydrogen molecule occupied no volume. And nobody could believe, if he believed in Newton, that they didn't have any attractive force when they got close enough together. So you knew before you found the curve didn't fit that the theory taken literally was false. Now when you falsify it, you have merely shown in the lab what you already knew from the armchair, that it was false. Having high verisimilitude, we ask, can we clean it up? Well, the nice thing about this example is that the way in which you clean it up flows from the very things about it that are false. From the very things about it that are false. And it was done by a Dutch physicist named van der Waals. Don't know the date. It was about 1870, something like that. And van der Waals says, the reason this thing doesn't quite work is that the molecules occupy a little space, so that we have to make a correction for the space that they fill up, because as we squinch them closer and closer together, if they have a fixed size and we're making the piston push harder and harder and harder and things are getting cooler and cooler and cooler, we have to take off calories when we're squunging it, of course, in that kind of situation. They're getting closer and closer together, and now we're getting to the point in the region where the volume that they occupy collectively is not negligible anymore. So we got to make a correction in the equation, and we'll just subtract some unknown constant little b. The way he did this is important for us as psychologists, by the way. And we want a plus on the other one, don't we? Yeah, A over B squared. I don't want to go into the details of this, partly because I'm a little rusty. This part, the pressure, the idea was that if you got a couple of molecules that are coursing along and are about to clunk against the piston, and that's where we get our p-value, is the sum of all those impacts on the piston head. And they get, if they're close enough together, they will have a slight attractive force due to Newton, as they're close enough together, one that we could have neglected. And when that happens, they will tend to collide and bounce off at angles different from the way they would have hit the piston. And that means that there's a little taking away of pressure due to the fact that they're close enough together that they agglutinate pairwise a little bit. And the reasoning there was, it's like the reasoning of the Q theorists and statistics about telephone calls and overloadings. The probability of such a collision as a function of the number that are, say, in a certain region close to the piston, and that number depends upon the density, because there's a fixed number of particles that we started with, and so that depends upon the density, and that's inversely proportional. It depends on the number squared in the statistics, and that depends on the density squared, and that depends on the volume squared, since we got a fixed mass that we started with. So V squared has to go downstairs. All right? Quite straightforward, really quite rigorous, but we got a constant up here. Now, you plot that one out, and that's a middling complicated sort of thing in that region. I mean, it goes up and then goes down a little bit more and so on, and it's an approximation to what actually happens in the lab, and that is that this thing becomes flat. I forget what it does way down here, but there's a period where it's essentially flat. You approximate that by something that is not quite flat, but is a lot better than this. I've got that slanting the wrong way, but don't worry about it. Now, the interesting thing here is that in the 1870s, one could not say what those two constants were. Not enough was known about sizes of molecules and such like, or even, well, structures of atoms, for example. You didn't know about such a thing as an electron. You thought that atoms were a little hard, uncuttable things. So you didn't have any theoretical basis for the constant A. And you didn't have any theoretical basis for the constant B. You could set sort of common sense extreme bounds on it, of course, but very extreme. It wouldn't help you do the math. And the reason that's important for psychologists is that we tend to think that if we don't have a powerful enough theory to generate mathematics, including the parameters, then we might as well throw in the sponge. And that's very commonly assumed in the social sciences. It's not necessary that you be able to derive the parameters. You have here what van der Waals had as a curve fitting problem. A and B have to be fitted, which one can do. And having chosen the values of A and B, which makes the best fit you can get from that function, then you ask how good a fit it is, and it's still not perfect, but it's a lot better than things were. Now, the interesting thing about that is that what begins as a falsifier of the theory in its idealized form, and which is still a Popperian falsifier of the theory in its idealized form, becomes now a corroborator of the theory, because thinking about how it was false tells us how to rewrite the equation and fit the facts much better. So we start out with a falsification, and we're not reneging on that. We're saying, yeah, it was a falsifier. But we knew that theory was false in its original form. It was an idealization about the damn particles, and we knew they couldn't be quite like that. Now we say, if that's the source of our trouble, we know how to fix it. And we fix it by putting the volume squared down here and adding it, and by putting the presumed volume, total volume of the molecules, and we don't know what that is, and subtracting it from the total observed volume of the system. And when we multiply those instead of this, we get a marked improvement in the fit. All right? A falsifier did not lead you to abandon the theory. It led you to say it was false, as it stood. You were far enough along in your theorizing, even before you got this empirical falsification, to know respects in which it was an idealization. You use that knowledge to ask, how could we change the equation if that's the trouble? And you do not have to have a theory powerful enough to generate the numerical values of the parameters. Another example, I'll give you one more and then we'll go on, is from astronomy. And it's the one that Lakatos is fond of, and that's the discovery of Neptune. Uranus is before Neptune, right? Neptune's farther out. Uranus didn't exactly follow Kepler's laws, and therefore it did not follow Newton's laws. Of course, Kepler's laws, as no doubt you've been told, don't follow from Newton's, strictly speaking, because of the perturbations. But they follow close enough that the fact that you can almost derive Kepler's laws from Newton's is a corroborator of Newton's. So what do? Well, you could say, oh, this is terrible. The law of gravity doesn't work. Or the laws of motion don't work. Maybe if gravity works the way Newton says, then this F equals ma business must not be quite right. So either we got to change the nature of the gravitational force, or if we hold that according to Newton, then we got to change the laws of force as they accelerate the heavenly bodies. And that was not a satisfactory move to make. So somebody, I forget his name, has said, we're not going to drop the law of gravity. It's got too much going for it. And we're not going to change the laws of motion, Newton's 3 laws of motion. They really collapse to 2, don't they? Because the first one is a special case of the second one, where force equals 0, and then, therefore, acceleration equals 0. We're not going to change the laws of mechanics as regards force and acceleration, and we're not going to abandon the law of gravity. How can we preserve them in the face of this very clear finding that Uranus isn't acting right? Well, if it's not acting right, it could be due to spooks or gremlins or angels, but let's assume it's due to the kind of forces we talk about in science, and that means it's due to some gravitational force. And where could that come from? Well, some other body. What's a good candidate? Another planet. Out farther. All right, then you go through the math, and you figure out where it should be. And then you tell the astronomer to point his telescope and look close. And sure enough, there is Neptune. Now, there you have a falsifier. But notice, that is different from this one. The falsifier here is not a falsifier of the general theory, but it's a falsifier that's only apparent given the assumption about the particulars, namely that the solar system only has such and such many planets in it. That's different from this case. One kind of adjustment is to alter the theory so that you can fit the facts. Here we didn't alter the theory. The law of gravity remains intact in our adjustment, and Newton's laws of mechanics remain intact after our adjustment. The adjustment is not in the laws, but in the statement about the solar system. And that's a statement about particulars. Now, I know there's a little problem about that, because we ordinarily speak of things like Kepler's laws as general. They are laws about our solar system, that's true, but they are laws about any such system. That is, you can derive the business about the equal areas being swept out and equal time intervals and so on for any system that operates according to least squares and in which the laws of motion hold. So Lakatos' favorite astronomy example is a good one, but it should be distinguished from the van der Waals kind of example, because in the Lakatos example, the theory as a set of general propositions is retained, is not corrected. What is corrected is certain assumptions you made about the particulars. Whereas in the van der Waals case, we adjust the theory itself, and in that case, we get a corroboration of what? Of the amended theory. And our faith in the amended theory is heightened by the fact that we knew how to amend it in ways that we knew beforehand but hadn't bothered to do the math must be wrong with the original theory before it was amended. Now, one reason that a crude proposition count doesn't wash is that if you write down the statements of a scientific theory and just list them, number 1, number 2, number 3, and so on, don't be bothered by the fact the scientist usually doesn't do that. You can do it from his text if you're playing the logician's game, right? And you can tell what's calculus and what's interpretive text and what's axioms and what's theorems. He says from which it follows, well, then you know that that's not an axiom, right? So even Skinner can be, although he despises the hypothetical deductive method, even Skinner can be formalized if you thought it worthwhile to play that logician's game with it. Well, when you do that, and you contemplate this list of statements, there are the statements of general form, for every x there's a blah, 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 or statements in mathematical format, you realize that some of these statements, call them primitive statements, from which the other statements, including the laboratory results, are derivable, are in some sense more important than others. And I have to say in some sense because I don't know how to explicate that satisfactorily. Let me start with the intuitively obvious examples to convince you that we have to have this notion of centrality versus peripherality, or what Lakatos calls the hard core of the theory versus the protective belt. If I told you, if you said, well, what are your views about animal learning, Meehl? And I said, well, I'm a neo-Skinnerian. And you were to say, well, what's neo about you? And I say, well, the way in which I'm neo, or hemi-demi-Skinnerian, or amended Skinnerian, is that I really am convinced that there is such a thing as latent learning. It's very clear that you get latent learning in space problems with the rat, maze, shuttle box, and the like. And you can, as I said last time, get latent learning in the Skinner box, although it's a little more work, partly because of the problem of the operant level, and let's not go into all of that. Let's say it's demonstrated there. Trapold said it was, and he didn't like it. And Gail Peterson assures me that you can get it if you do it right. So we get latent learning. Now, there isn't an easy way to generate the phenomena of latent learning out of Skinner's postulates. That is, whether it can be done by some statement, I don't know, but Skinner has never done it, and the Skinnerians who write about learning in general don't tend to address themselves to it. And there's a paragraph in Catania's book discussing it, which is one of the stupidest paragraphs that I've ever read in a scientific book. And they just don't like it, so they don't talk about it. The Hollians didn't like it, but they felt they had to talk about it. The Tolmanites, of course, liked it, and the cognitive psychologists love it. Well, now, if I told you, you know, I really am a Skinnerian, and I really think that's the right way to go about studying behavior, and all of those different semi-quantitative things about the type of scalloping and so forth on different schedules, all of that is fine, and great stuff. This is it. However, there's this irritating latent learning thing. The little scoundrels seem to learn sometimes about what leads to what without being reinforced for doing something, and without showing a change in strength, which is part of the notion that you have reinforced them. That's part of the definition in Skinner. So I have to accommodate that. I wish it weren't around. But I will add a postulate, and then we'll add some kind of SS connection postulate. This wouldn't be hard to write. It would look a little Tolmanite, but you could write it in Skinnerian language. And Fred Skinner might not like it, but he wouldn't have a temper tantrum. And he might suspect that something was going on that you weren't clear about, but he'd never been interested enough even to talk about it, as I told you. I don't think it would be absurd for a person to call himself a modified Skinnerian who put in a special postulate to deal with latent learning alone. He's got an amendment. It's not a denial is it? It's an addition. It's an additional way that the rat can learn. And you wouldn't have to use any cognitive language, a la Tolman. You wouldn't have to talk about expectancies. So it would be sensible for such a person to say, I'm a neo-Skinnerian, I'm a modified Skinnerian, I'm an amended Skinnerian. But now suppose I told you I was a neo-Skinnerian and you said, what's neo about you? And I said, well, I don't believe in reinforcement contingencies. That would be loony. I mean, you'd say, what is the matter with you? Why are you must not, what, are you kidding? It would be nonsense to say I'm an amended or modified Skinnerian. I don't think that reinforcement contingencies have much to do with behavior. Crazy. Or let's say I tell you I'm a neo-Freudian, and you want to know what's neo about me. And I say, well, I recognize there is such a phenomenon as penis envy, and it's the female equivalent of castration anxiety in males. And I know what Freud heard when he had women on the couch that made him have those associations. It is interesting, that, especially with dreams, how the theme of being put upon or overpowered or not treated well because you're a girl and various things like that is often linked to the symbolism of somebody stole my cigar and that kind of stuff. I mean, it's really interesting. As in the case of males, when deeply threatened by the company is going bankrupt, why somebody's out to cut the magic organ off and so forth. So I don't have any doubt as a psychotherapist that the thematic material really is there if you listen. But of course it doesn't prove what Freud thought it proved. That's a different question. Just as there's no doubt in my mind that there is a deep linkage between anal associations and the theme of hostility and autonomy, much greater statistically than is true of the theme of eroticism and dependence. So that there is something to the idea that reaction formation and displacement and those mechanisms are characteristic of our way of handling hostile and autonomous and aggressive wishes, and that in people's associations on the couch, that is frequently tied up with connections with toilet paper and the Battle of the Chamber Pot and all of that kind of stuff that's in Ernest Jones's famous article. I grant all of that, but that doesn't prove there's such a thing as the anal libido, right? And it doesn't even prove or tend to prove that it's due to your toilet training. I mean, if there is a connection there, which the developmental psychologists have not been able to confirm, but if there were some piddling correlation there, that could simply be due that what? We could say Minnesota style, mothers who have more genes for obsessional control and character armoring are more fuss-budgety about toilet training, and the kid inherits those obsessional genes, blah, 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 blah. I can spin out a Bouchard theory of this, which is just as plausible as Freud's, and not mention the Battle of the Chamber Pot at all. Okay. So I tell you, I am a neo-Freudian, but I have some doubts about the centrality of penis envy in women. There are some who have it, but I don't think that's such a big thing. And I think if you try to explain female neurosis in those terms, that you're really greatly overdoing that. Well, Freud might not be entirely comfortable about that, but I don't think you would say it was goofy to say you were a modified Freudian if you said, I'm going to subtract. I just don't think that's such a big thing. Maybe it was a big thing for Viennese middle-class ladies in 1895, but I don't think it is anymore. But if I told you I was a neo-Freudian and you said, why neo? And I said, I don't believe in unconscious mental processes, right? That would be madness. Or if I said, well, I don't think that neurosis has anything to do with conflict, so I've amended Freud. Well, I've gutted Freud, right? I mean, what's left if I say no unconscious processes? You can't be a neo-Freudian then. So it's obvious that we need some notion of the centrality of a postulate in a theory, contrasting it with its peripherality, and that any way of getting at theory's verisimilitude that doesn't pay attention to that is not going to be satisfactory. You can't just, that's one reason It's only one. I think it's the big one. Why you can't measure verisimilitude by a nose count, by a sentence count. Because that means that a core concept would get the same weight as a very peripheral one. With Hull, you could do the same thing. The habit strength postulate in Hull's theory is core. Every derivation chain in Hull's 1943 book will involve the habit strength concept postulate, either explicitly or implicitly. Now, it is true that deriving some things about, say, reactive inhibition or whatever in Hull, he might not mention the growth of SHR, but if he described an experiment to you on, say, stimulus generalization, that's another one of his things, you know, he's got that decay thing, and he didn't tell you that the rats who gave these points out here had only been reinforced 12 times, and the ones who gave the other side 50 times, you would know that was unscientific reporting. So that means that although he doesn't use the SHR growth function formula when he's talking about an experiment on reactive inhibition, he presupposes that you have equalized the habit strengths of the experimental and control group, right? So in that sense, the law of the growth of SHR as a function of number of reinforcements is core. Whereas something about conditioned inhibition, for instance, is peripheral. There weren't any Hullians in my youth who didn't believe in SHR formula, but I knew a number of Hullians who thought that he shouldn't have invented that conditioned inhibition business. And a lot of them who didn't like the reactive inhibition business. All right, so we have to have, in thinking about verisimilitude, we have to have some kind of a notion in our meta-talk as to the centrality and peripherality of the postulates. And a theory gets more black eyes from the fact that from the inference that one of its core postulates is off than it does from having one of its peripheral postulates off. And in fact, one can easily think of cases where having 3 or 4 peripheral postulates wrong wouldn't bother the theorist as much as having a core postulate defective. Now, talking about core and periphery is not very rigorous language, and I'm sorry about that. I don't know how to fix it up. If I were pressed, as I was recently by one of my logician colleagues in the Philosophy of Science Center, to explicate it a little more rigorously, it would go sort of like this. One has an experimental domain in mind. All of the things that a rat in a Skinner box could do. Just imagine yourself to be ringing the changes on all of the experimental parameters. Well, if we only have levers and not chains to pull, for example, we narrow down the operant to one thing. Imagine, just fantasize that you have all possible designs. That doesn't mean all possible numerical values assigned. That goes into the curve. But all possible designs. So we're going to fiddle with hunger and thirst and sex and 2 levers and 1 lever and so on. It's that huge. It's finite, though, isn't it? We're not going to get into these uncountability and measure type problems that Popper gets into with verisimilitude. It's not only countable, but it's finite, however big. I mean, people, if everybody started doing rat experiments in the Skinner box, we could probably do all of the possible ones before the sun burns out. And if you play the logician's game that you allow yourself that, no matter how big it is, it's finite. Now let us imagine all of the well-formed formulas that we could write that would describe the outcomes. And now let's cross out all the ones that don't replicate, right? So you've got all the replicable woofs or whiffs that there are in the domain, in the fact domain. Now for each one of these, you are going to ask whether it can be coordinated with a sentence in the theoretical language. whether that theoretical language is Skinner's, which would be the easiest because it's so close to pure dispositional, or Hull's, or Tolman's, which would probably be the hardest. But you imagine this big set of all the possible experimental well-formed formulas that replicate, and then you ask that each one of these be coordinated with a statement in the theory language, and then you ask whether I can derive that statement that's in the theory language from the postulates of the theory or not. If not, the theory is incomplete. That's one definition of completeness in logic. It's the crudest one. For us, it's the useful one. The more elegant ones of categoricalness and so on we don't discuss in this course. The useful definition of completeness for a postulate set is that it entails all the theorems that you want. And that's crude, but that's how Russell and Whitehead described it in the Principia. When is a postulate set in pure mathematics complete? When it gives you all the theorems that you want. All the ones that intuitively you want, all the ones that the mathematician says he needs. Okay? So if all of the well-formed formulas in the theory of language, in the theory language that we need to associate with all of the well-formed formulas in the observational language flow as theorems, then we will say that the system is complete. That means a postulate set that's empirically complete. It need not be categorical in the formal sense of the logician. The heck with that. It's empirically complete if it generates all of the woofs that coordinate to observational woofs that we get in the lab. Then we could look at all those derivation chains. Some of them would be very short, some of them would be quite long. All the derivation chains from the postulates to the facts, and we would, for each postulate, inquire how many of these derivation chains contain it crucially. All right? And if we find a postulate that appears in every derivation chain, at least implicitly, like the SHR growth thing in Hull, we would say that's a core postulate. Any one that is missing from at least some of the derivation chains, we will say is not core. And if you want to quantify degree of peripherality, then you would say, well, in that case, I will do a nose count. It'll be better than a literal count about postulates. I'll do a nose count, and I'll ask how many derivation chains of all those that I need to derive all the class of all the facts that I can observe contain postulate number 7. And if only 2% of them do, it's highly peripheral. And doesn't that fit your intuitions? If I had to change a postulate because I was in trouble with only 2% of the 20,000 experiments in the rat lab, then you would say that's not a terribly profound modification of the theory. And if I had to change one that was doing fine for 90%, I'd be in pretty hot water. That would be my general approach, to try to quantify peripherality, centrality, and that's the way I would go about it if I tried to fix up Lakatos, who never got around before his death to explaining how you tell what's the hard core. The hard core of the theory, in his view, this is his Leninist side showing up again. The hard core is the one that you protect at all costs and which you do not permit the modus tollens arrow to be directed against. You only permit the arrow of the modus tollens to be directed at the periphery. And the periphery includes, in Lakatos, peripheral postulates of the theory, and then all sorts of other theories that dragged along as auxiliaries, and we'll talk about that maybe today. If I were trying to advise a logician, they haven't asked for my advice in this matter, unfortunately, but if I were trying to advise a logician how to go about setting up a meta-theoretical function of some kind or index of verisimilitude, I would not try to do it with this infinite class of consequence business. Syllogism, conclusion, all crows are black, 2 observational predicates. You can derive that without knowing what glops means, right? More complicated cases are more fun, but the essential point there is that I can have a syllogism that contains a middle term, which is an undefined term, and I don't let you in on the definition, and I can still derive as a conclusion a statement from which the middle term, of course, in formal logic has been eliminated, and if the middle term is the theoretical term, And the subject and predicate in Aristotelian logic are the two observation predicates. Then my logic machine, chug, 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 spits out a statement which contains only observation terms. Happens all the time. So we have, in a typical scientific theory, what we have is a set of theoretical postulates, P1, P2, Pk, and then we have a set of mixed postulates, and then we derive from that statements which are all observational. And that's what makes a scientific theory empirical. If the structure, the overlapping of the terms and the formal structure of the theory were such that you couldn't grind out any statements that contain only observation terms, then you wouldn't have any way to test the theory. So that's what makes it empirical. I do not say that's what makes it meaningful, since I don't hold the verifiability criterion. But that's what makes it an empirical theory. That there is at least one, and usually many, at least one sentence that could be ground out by applying the rules of logic and mathematics to the theory. There's at least one statement that can be ground out that does not contain theoretical words, but contains only the formal terms of logic and mathematics and observational words. Now, those of you who've taken a philosophy of science course or even a general philosophy course are aware that there is a continuing controversy as to the distinction between observational and theoretical words, and that's an important thing for the philosopher. I do not think it's that important for us, so I don't spend time on it here. I admit there's a fuzziness there, but the word black as a predicate is an observational predicate, and the word libido is sure as hell not. Now, that there are some terms that you have some trouble with arises partly from the fact that the advanced sciences use instrumentation. And so one can ask whether, for example, saying that the current flowing is so many amperes, is that an observational statement? Well, it is if you believe in the ammeter. And since we have A, a theory of the ammeter, and B, a calibration of the ammeter, and since we have good reason to think that the ammeter isn't different during the day from during the night, and so we won't have to correct for that, and we got a whole bunch of things that don't affect the system. We rely on the ammeter. That means we got a reading here, and it says 237 milliamps, and we count that as an observational term. I really don't find it very exciting to hassle that. I mean, if somebody says, I don't have faith in the ammeter, well, then we'll have to go back to the drawing board and discuss why we use this particular device. So assuming that there is some distinction between observational terms with or without instruments, the late Grover Maxwell called them quickly decidable with high reliability terms. That's a dog, decidable with high intersubjective reliability. And if you don't get quick decidability, if you have to think for 5 minutes and go through a lot of math, then it is not an observational predicate. Or if people don't, normal people with 20/20 vision who aren't psychotic and having English as their first language don't agree that it's a dog, then it's not an observational predicate. Yes?
Well, are the mixed terms your predictions, or what are they like?
The terms can't be predictions. The sentences are the predictions. The mixed terms are not observational predictions, the mixed sentences, because they have a theoretical word tied up with an observational word. Or maybe there are two theoretical words tied up with an observational word. But they are, I am treating these as part of the postulates. So the postulates include, I'm sorry, I didn't explain that very well. The postulates include statements that contain only theory words. We always take for granted that we are allowed mathematics and logic, see, so that they can have a derivative or an integral sign or a plus sign or an if-then, and then they got some theory words like libido or habit strength or positron or whatever. And then we have these statements that relate a theory word to an observational word. As, for example, Freud's 1895 theory, dammed up libido results in anxiety. That's a purely theoretical postulate, taking anxiety as a theoretical concept. But anxiety results in, then you look at his list in his description of the anxiety attack syndrome. And it's a disjunction of things like palpitation, tachycardia, dyspnea, a fear of death, blah, 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 and a long list, and even anxiety equivalents like I got to eat 3 Hershey bars at 2 a.m. And that's in his list, too, that kind of stuff. So that's a disjunction, but it's observational that a patient eats 3 Hershey bars. It's observational that somebody's heart is pounding and so on. So the postulate that says when somebody is having a lot of anxiety, he will have these and these somatic symptoms and these subjective verbal reports is the mixed type, whereas the statement that dammed up libido results in anxiety is of the pure theory type, all right? Now, if you get dammed up libido by sexual arousal without orgasm, which was his 1895 theory, Dave Lickens translates that as Freud's early theory was that anxiety is rancified libido, and that's rather good. And there is something to that, you know. We shouldn't throw all of that out. I'm not saying that he was right, that was the specific etiology, but Pavlov already showed about 1925 that a male dog in which you induce an anxiety state by conflict, not sexual conflict, but food conditioning conflict, and if you allow him to copulate, his anxiety and neurosis is greatly improved. So we shouldn't throw all of that out. And Freud never did, by the way. In the 1933 lectures, he says he never completely abandoned the theory of the connection between rancified libido and anxiety. All right, so let's say that we can operationally, behaviorally get at the fact that somebody is being sexually aroused and is not having orgasms. And so that's a theory-observation linkage. And then we have the theory-to-theory term linkage between dammed up libido and anxiety. And then we have the theory-to-observation linkage between anxiety and tachycardia. And that means that we now have a linkage between constant, frequent, high sexual arousal without satisfaction, tachycardia, palpitation, munching too many Hershey bars, etc. All right? So even with Freud, you see, you can play the logician's game. What we do is put the truth-grinding machine on top of the postulates, and it turns out that the structure of the theory is such that we can grind out some statements that connect these inputs to these outputs. This is inputs that behaviorally describable in terms of the patient's sexual life, and these are outputs in terms of the anxiety attack. Okay? Well, the first thing I want to look at when I look at a theory and ask what kind of a theory this is what kinds of entities it speaks of. And it turns out that there aren't too many different kinds of entities. Russell said there's only one, events. That's a little broad for our purposes. But let me give you Meehl's ontology. What kinds of things the world has in it. Now, I'm not prepared to defend this in a metaphysical way, but I have found it very useful in reflecting on psychological theories and theories in sociology and the like. And it's one step up from what you could call a rock-bottom metaphysics. And you could share my list without sharing my particular metaphysics. Is important. What kinds of things are they? My list changes. I don't cross things off, but I add things. So if you've talked to somebody or looked at any notes from this course 3 years back, it won't be quite like this. But that's not just senility. I have learned something in the meantime. What kinds of entities are there? I'm using the word entity in the broadest possible sense, like St. Thomas would. Ains, something that exists, something that has being. Substances. I used to leave that one out because I thought I could subsume it. I am not using the word substance here in Aristotle's sense, but in the sense of the chemist. Each of the elements is a substance. Structures. I include as an extreme limiting case of structures a simple, if there are any simples. So if there are any simples, then I'm counting gluons and quarks as structures. But anything above the level of quarks and gluons are obvious structures. That is, they have these other things as parts. So a neuron is a structure. A chair is a structure. The helium nucleus is a structure. The brain in your head is a structure, and so on. Is the superego a structure? Metaphorical structure? Freud speaks of it as having structural properties. So structures are made out of other structures that are made out of other structures. In the Comte's pyramid of the sciences, we are way up here with neurons, and the sociologist has got social class, and the economist has got marginal propensity to presume, to consume, and so forth. Synapse is a structure. A Hebbian cell assembly is a structure. The fact that you might have to do something functional, studying a process, to identify a structure doesn't mean it's not a structure, right? So in a Hebbian cell assembly, which we now have revived, my neuroscience friends tell me, and now they're modules, and by God, they're there in the cortex, stacked up next to each other. And so it could be that I have some interlacing of neurons, and I would have to know functionally what is controlling what synaptically. That wouldn't stop it from being a structure, would it? Things can be interlaced and be a structure. An entity, in my sense, does not have to be lumpy or thingy, like a rock, in other words. Events. The neuron spikes. The patient faints. The rat has a fractional anticipatory goal response, RG, at the choice point. I am experiencing a hunger pang. Those are events. States. Jones is depressed. I am thirsty. This particle is charged. Dispositions. Dispositions, and some people today like to divide them into active and passive, and they call active dispositions powers. If you like that terminology, that's okay. Those are the kinds of things where you say if, and you describe some operation, then, and then something else will happen. A large part of the vocabulary of ordinary life, when you look at it closely, as the logicians emphasize, is dispositional. One can even say colors are dispositions, for instance. Probably the majority of philosophers would say a surface color is a disposition. That means it has a tendency to give you a blue experience when you look at it in normal light with normal vision, or alternatively, its chemistry is such that the particles, the molecules, are selectively absorbent and reflective of certain wavelengths, and that's a dispositional remark as well. So some logicians have said that all of the properties of things are dispositions, whereas my friend Wilfrid Sellers used to say, no, 95% of them are dispositions, but the other 5 have to be stuffing properties. And he never explained exactly what he meant by a stuffing property. In psychology, of course, they're all around us. I mean, I attribute a certain habit strength or a certain operant level, or I use a trait name, or I use a clinical term. I say Jones is a hysteroid. That doesn't necessarily mean that Jones has a paralyzed arm, but it means that he, more commonly she, it turns out, has a talent for that. And that means that if you operate properly on this individual, you will get a paralyzed arm. But if you never do, then that person could go throughout life being a hysteroid personality, what is it now in DSM-3, histrionic, and never get a paralyzed arm. Just as a person can have a talent for schizophrenia, witness the fact that his MZ twin has it, and go throughout life without decompensating. And has what, 45% chance of doing so, if you're lucky. So dispositions are common in all of the sciences, but it's our bread and butter in psychology, whether we're learning theorists or perception people, and certainly if we're clinicians. When we talk about patients, most of what we say is attributing dispositions. And that can be in technical language, such as histrionic or psychopathic or schizotypal, or it can be in lay language. All the trait names, that vast list of 18,000 trait names in the Allport-Odbert list, are almost all of those are dispositional statements. You recognize dispositional statements in common life and to some extent in physical science by the fact that they're words ending in able and able, as flammable, soluble. When I say sugar is soluble, is water soluble, what do I mean? I mean that if I take a lump of sugar and put it in water, it'll go into solution, right? So it's a dispositional predicate. Flammable, frangible, malleable, ductile, all of those words from physics and chemistry and engineering are dispositional predicates. And it's important to recognize that dispositions, therefore, can sometimes have to be inferred from other dispositions because they are not realized, to use Carnap's word. If I never put this sugar lump in water, it will never be dissolved, and we don't want to say, well, in that case, it doesn't have solubility. Solubility doesn't mean in solution. It means having the capacity to go into solution. So many dispositions remain unrealized. That's all right. And then finally, some student pointed out I had left out fields. I think the reason I left out fields was my positive youth. As a positivist, one learned to define fields as in the gravitational field and electromagnetic field dispositionally. So you think that you've covered fields when you've got dispositions in a list. That's a little more positivistic than I now feel, so that if you insist on adding fields to the list, it's okay with me. Not very likely to occur in psychology to any extent, although a little bit. You know, homing pigeons maybe use it, and Levinian fields, if you believe in that stuff. Well, that's Meehl's ontology. Now, I claim that that list is an adequate list to analyze practically any concept that you come across in the social sciences. Yes, sir?
Where would you put the A and B process from the
Say that again?
The A and B process from the point of process theory?
I don't know what that is, so you'll have to tell me.
Solomon and Corbett?
Go ahead.
Well, I don't want to get into it.
Well, when you say it's a process, I am going to almost
Process, I think the structure. Use metaphorically.
Uh-huh.
Maybe now what that is like, Isomorphism.
Well, without knowing more about it, I don't know what I would say. What you have to do, you cannot trust the writer, by the way, to tell you which of these he's got. What you have to do is look to see what he says about the entity and see if you can catch him treating it as an event, as a state, as a disposition, or as a structure. And what happens frequently in psychological writing is that it is not clear because he moves around, and that's clarifying. That means that he hasn't made up his mind what kind of a concept it is. Let's take, for example, Freud's superego. When you speak of a rigid superego, that sounds rather structural. Could we render all of the meaning of a rigid superego into dispositional language? I suspect we could. I guess Freud wouldn't like that because in the 33 lectures he says, after he draws that famous picture of that shattered egg with the bump and so on, he tells us that he hopes that he has convinced the reader that this is not just a manner of speaking, that he really means means to convey the reality of the psychic institutions. My hunch is, although I have never really tried it, is that you could translate practically everything Freud needs to say about a rigid superego, or that we would sometimes say of a psychopath he has holes in the superego, that you could translate that into terms of dispositions, but I have not actually done it. But it's important that you cannot trust the writer. if he gives you a meta-talk remark and classifies it as being an event or state or structure, you can't necessarily trust him without seeing where, looking at the sentences in which it plays a role in a derivation chain.
In general, we characterize a process as, say, an event that brings about a change in state.
That's good. That's very good. And frequently you would have a problem here because some people might say, well, as far as I can tell, states are just events that are strung out for a longer time interval. See, we could say I stumbled. How many flights of stairs, as one student asked me in class one time, how many flights of stairs do I have to keep falling down before I change from saying he's in the state of downstairs falling versus having an event? Well, the distinction between these two is fuzzed up, and it's no big problem which way you say it, but it would be quite different if I got mixed up between either of them and this, wouldn't it? So that the important kinds of events are when one structure or substance undergoes a change in state or impacts another substance or structure and brings about another change in state. And then we have the case in which it changes dispositions. Dispositions come in orders. The power to attract that a magnet has is a first-order disposition. That iron or permalloy are magnetizable and a lump of wood isn't is a second-order disposition. That is, it has the disposition to acquire the disposition we call being a magnet, being magnetic. Okay? Now that we know that we can transform some chemical substances into others, you could say that something has a third-order disposition if I can, by physical means, transmute it into something that has the property of becoming magnetic. So then we have a third-order disposition. And the classic treatment of that problem is C.D. Broad in an examination of Hamilton's philosophy, but you don't have to be interested in Hamilton's philosophy to enjoy Broad on dispositions, and that's reprinted in Feigl and Sellers, and it's a beautiful paper. It's the great paper on dispositions and orders of dispositions. You can keep going up in orders of dispositions until you get to what Broad calls supreme dispositions. Capitals, as I remember. And a supreme disposition is that absent which the substance would not be what it is, but would be some other substance, all right? So I presume that means in modern chemistry, since we transmute elements, that the supreme dispositions are something that it's not that atoms have them, but electrons and protons have supreme dispositions. That's a little bit like an Aristotelian essential property. In other words, if it doesn't have this disposition, then it ain't iron, it's something else. Well, now that list also helps me to think of what kinds of laws we have in the various sciences and what kinds of theories. And most of the laws that you come across in any science turn out, I will not say all, to be compositional, functional dynamic, to use a phrase that Skinner introduced and then quit using, and developmental. And just as single laws of various sciences usually take one of those three forms, I'm not claiming every one, but again, I would say 95, 99%. So whole kinds of theories differ in this respect. Compositional theories are theories that say what something is made out of, what its parts or components are, and how they are arranged. So the Rutherford theory of the atom was a structural compositional. I can add, if you like, structural to this because it can be what substances make granite or what elements are baking soda. Compositional structural. And functional dynamic are the ones that involve Aristotle's efficient causes. If you do this, then this will happen. If you apply this force, you'll get this acceleration. If you reinforce the rat, the operant strength will increase, and so forth. They refer to changes in state bringing about altered dispositions over time. And then you have developmental. Whether that's a special kind of theory, I'm not sure. It almost always has these as composites, but in order to keep the Piagetians happy and evolutionists and so on, we need the developmental kind of theory. But they're not confined to the life sciences. I mean, the theory of evolution, of course, is a developmental theory, and that's in the life sciences. But the theory of the Big Bang in cosmology is a developmental theory. It narrates the history of the universe and says that this turned into that. In geology, the theory of continental drift, now called usually the tectonic plate theory. The theory of continental drift was invented by a German geologist named Wegener, and unfortunately the poor guy died as a laughingstock, and then 30, 40 years after his death, it is successfully revived and is now the going theory of how the Earth works, so to speak. Bits and pieces of developmental occur in theories that are mainly functional dynamic, as in nuclear physics. If I say if you have an electron and a positron that collide and they mutually annihilate and they give off a photon, you could say that's a kind of developmental concept, couldn't you? Yes.
Is there a particular problem with developmental theories in neuroscience, such as the Big Bang and evolution?
You mean you think they're harder?
No, unable to resolve such problems. Is that a problem kind of unique to those theories? I was just thinking of that when you were giving examples of them that.
Well, I have not, I don't know how I would answer that.
There was some debate, over evolution. It was some years ago that I read the article. So just on that sort of thing, that a lot of the...
You'd have to make a list of all the developmental theories. Reflecting on your question, my instinct or my intuition is to answer it, yes, it seems like they are somewhat harder to test. But why would that be? Well, theories of history are classified this way, like theories about the fall of Rome. Have we discussed that? There are 7 major theories about why Rome went down the tube. And it's very interesting that high cultures always go down the tube. That's a deep one. The historians don't like to talk about that, but that's that deep one. I mean, Spengler in The Decline, which is a goofy book, but a brilliant book. I'd recommend it to you if you can stand that Wagnerian Teutonic style. Spengler, people react to Spengler. It makes me think of what Mark Twain said about Wagner. He said, Wagner is not as bad as it sounds. Well, Spengler is a Teutonic mystic and dogmatist and so on, but it's a brilliant, profound book, I think. And then Toynbee, of course, Spengler had 8 cultures and only talked about 3 to any extent, and Toynbee had, 21. Toynbee says just because they've all gone down the tube doesn't mean it's unavoidable. Well, I accept that, but my response to that remark is if I went to my doctor and said he diagnosed me as having malignant melanoma or glioblastoma multiforme, and I said, well, I've been told that all patients with glioblastoma forme are dead within 6 months, and if he said, well, I've only had 22 cases and they all died within 6 months, I would not be reassured. A historian and political scientist more scientific than either Toynbee or Spengler at Washington, not Washington, Georgetown, named Quigley, managed 26. But it is interesting, isn't it? 26 high cultures in which we have enough records to say anything intelligent about them all went down the tube. And over half went down internally first.
I mean, Rome didn't go down the tube because the Huns invaded. The Huns successfully invaded because Rome was down the tube, politically, sexually, religiously, patriotically, agriculturally, and economically. It was down the tube in all possible ways. And the debates continue as to why Rome, which has been researched apparently more than any other with this in mind because of the great importance of the, quote, fall of Rome for our society. And there are these 7 theories. And the only one I can remember, because it strikes you as goofy at first, but some have taken it very seriously, is that the Roman upper class got lead poisoning from drinking all that wine in those pewter vessels, because it's been shown that if you drink booze, even wine, in pewter vessels, you get a certain amount of plumbism. So the idea is that the poor people were drinking out of, the proletariat was drinking out of wooden ones, but the upper class is getting lead poisoning. Well, I don't know the answer to your question. It's basically a statistical question, isn't it? If we just counted all of the theories that are developmental, theories in geology, in cosmology, the theory of evolution, which still continues to be in funny state, you know. It's only when the evolutionists are fighting the Baptists that they make out that it's in great shape. Among themselves, they know it's some very serious problems. It's not all it's cracked up to be, in my humble opinion, and I'm not a Southern Baptist. But anyway, theory of evolution, developmental theories, Freud's theory of the libido, the stages of the libido. You've got the oral and the anal, and then you've got the anal expulsive versus the anal retentive, and then you have the phallic stage. Piaget, or Kohlberg's Piagetian theory of ethical development. I don't know the answer to that, but my impulse is to say, yeah, it seems to be harder to settle the darn things in it. And we do have the problem we can't manipulate the variables. We have to take the record as it comes. That is, geology, paleontology, and the fall of Rome and so on are documentary disciplines in a broad sense. Paleontology and history are both documentary disciplines. And so you have historians, for instance, who are so skeptical along these lines that they think there cannot be any such thing as a general theory of history. And I have been told by historians that they don't quite know what they mean by an explanation in history. Like if somebody says, why did World War I break out? Well, the Kaiser was a manic depressive, and Nicholas II was a skitz with a hysterical wife, and so it goes. And you can find historians who say it's totally feckless to discuss that. I wouldn't even carry on a conversation. Would the World War have broken out on some general, say, Marxian grounds, as the Marxists would say it would have, even if the Kaiser had not been such a nut, and so forth? I've just been trying to read Croce. I think I'll give it up. But Croce, for example, says that if you play that if game, it's really being silly. Although he says if it helps you to advise people to think more closely before they act, he says it's all right to say if the leaders of Germany and other countries had not been so nervous, the war wouldn't have happened. That's the kind of stuff you get in Croce that I just don't understand. I mean, I don't understand why, if he tells me I cannot say that if kind of game, then in what sense would saying it be a sensible way for me to control my conduct? But anyway, I don't know the answer, but it's a very interesting question. And I suppose the most obvious reason, if you're right about your conjecture, is the fact that you can't do experiments on the past. So you have a documentary record, which is imperfect, and you have to piece together the causation as well as you can. The other thing about developmental theories is that for them to be intellectually satisfying, some people want them to have built-in functional, dynamic, and compositional components. If the developmental theory, which doesn't, so to speak, say why something turns into something else, in terms of a law of this class of theories, they tend to think is not much of a theory at all. Well, now, if one were to accept some such crude list as the furniture of the world, Meehl's ontology, then the first thing you would ask, if you want to compare theory T1 with theory T2, I'm not talking about verisimilitude now, but just saying how similar these two theories are to each other. You want to ask how similar T1 is to T2, is that you would list the entities, the kinds of entities, and you would ask yourself, are they the same kinds of entities? If you found, for example, that both theories had 3 substances and 5 structures and 7 dispositions, and that they drew the causal connections in the same way, then you would say they are really very similar, even if the one uses logarithms and the other uses the square root in one of the laws. The connections between the entities, whether they are of a functional dynamic kind that says if you change this variable, this will change, or of the compositional kind that says this is made out of this kind of stuff or these kinds of things arranged in such and such a way. And if you could see that there was a structural resemblance of the kinds of entities and their connections, then you would say that these two theories are very similar, even if the words that the theorists are using are quite different. On the face of it, they seem different, but when we ask, well, let's see, what are the actual postulates here? This one postulates a certain kind of entity, and that corresponds to this one over here. And the limiting case is what the logician calls a formal isomorphism. That is to say that one can draw 2 networks, drawing strands connecting the elements of the network, and there's a one-to-one correspondence between them. And that would mean that even if the vocabulary is different, that the theories are formally indistinguishable. Well, after you make your list of entities, then you go on with, I just said that, how they connect, compositionally and functionally. If you've drawn functional connections or time changes in a developmental type of statement, you can then ask, well, what's the sign of the first derivative? You don't claim to know what the function is. You just ask, does x go up with y or down with y? So you got a strand in the net connecting this entity with this entity, and it says that this state of change of state in this one does this to this one, and then we ask, well, is that increasing monotone function? Then you could go on and ask, what about the sign of the second derivative? So I might tell you, well, I don't know exactly what this law is, and I'm not going out on a limb and conjecture that it's a growth function, but I will tell you that I think that the first derivative is positive throughout, and the second derivative is negative throughout. So we have, in that case, we could have a growth function, we could have a power function with the exponent less than 1, anything that will give us a monotone, increasing, decelerated function will do. And that I might even arrange the first and second derivatives or partial derivatives as regards their size and still not tell you anything numerical. I might say, for example, I got some output function of behavior that depends on 2 input things like hours of deprivation and brightness of the stimulus or how far we are from the conditioned value, and I got this function of x1, x2 input things, and I tell you that the partial of that with respect to x1 is greater than the partial of that function with respect to x2 everywhere. So I tell you x1 is a more potent influence on the output y for all values than x2 is. But I still didn't tell you what the function is. I just tell you that x1 gives you a bigger thing than x2. For the discontinuous case that you're familiar with from design of experiments, that tells you that one main effect is bigger than another. And then I might ask you, well, let's see, does the rate of change of, does this one of these derivatives contain the other variable? I differentiate the function partially with respect to x1, and then I differentiate that partial derivative with respect to x2, and then I ask you, well, what's the sign of that? I tell you that the impact that x2 has on the output function is greater when x1 is big than when x1 is small. Well, you all learned about that, too, for the discontinuous case. And in design of experiments, that tells you that there's a significant positive first-order interaction effect, right? That's what this is just the continuous form of a Fisherian interaction effect. How much mileage I get from potash depends upon how much rainfall. Okay? Incidentally, I have had students on oral prelims, if asked to define interaction, I've had students say it means that the effect of the two things being present is significantly bigger than the effect of either one of them separately. And that is terrible, because that is not what it means. What you mean when you say there's an interaction effect, if Y is the output, Y with A present and Y with A absent when B is present, Y with A present minus Y with A absent when B is absent, and interaction means that that difference is not zero. That means that the effect of Y when B is there is greater than the effect of Y when B is not there. And that, of course, is much different from merely saying that A and B gives you more than A does, or that A plus B gives you more than B does. This is the meaning of interaction, and the continuous form of that is the case where you have a second-order mixed partial derivative that's non-vanishing. Well, I could write down a whole bunch of statements like that about my entities. And I could say, well, I have these two theories, and they've got the same kind of entities, and the same positions, so to speak, in the network, connected with the same strands, but this one makes this influence much more powerful than this theory makes it. And so then there would be a little difference in the theories appearing, but it doesn't appear until I start talking, say, about the derivatives. 1 minute to 5, I think we should stop at that.